Good morning, everyone. Thank you for being here today. So, we are excited to present to you our project title, which is Diagnosing Mental Stress Through Brainwave in the Living Environment. So, this project integrates IoT technology with environmental and EEG system to provide innovative solution for mental stress assessment. So, our team consists of 5 members, which are Muhammad Fikri, Muhammad Ashraf, Nurul Azri, me, Muhammad Ainul Hayat, and Muhammad Azwan Ashraf. So together we have collaborated to design and develop this system, which we believe has the potential to revolutionize how we understand and address mental health challenges.
As for the introduction, mental stress is a significant health concern in modern society, affecting various aspects of daily life. While moderate stress can enhance focus, excessive stress often leads to negative outcomes like depressive symptoms and emotional strain, especially during challenging tasks or competitive situations. To address this, scientists are exploring innovative tools such as EEG, which records brainwave activity non-invasively. By combining EEG with environmental monitoring, like air quality sensor, which is MQ series, and temperature humidity sensor, which is HG3, we can better understand how external factors influence brain activity. This approach offers valuable insight into the connection between our environment and mental well-being. The findings could lead to adaptive environments that automatically adjust conditions to promote mental health, transforming how we design and manage spaces. So for this project problem statement, environmental stresses like noise, air pollution, temperature fluctuations, and inadequate lighting are increasingly prevalent in urban and indoor settings, significantly impacting mental health and human performance. While those stresses are known to affect physiology and behavior, their real-time influence on brain activity and mental state remains poorly understood. Traditional methods often fail to capture the complex interactions between these environmental factors and neural response. This gap underscores the need for an integrated approach that combines environmental monitoring with EEG-based brainwave analysis. By doing so, we can better understand how environmental stress affects emotional and cognitive states, paving the way for innovative solutions to optimize mental well-being and performance.
Now, we move to the objective part. Our group HG3 has been listed 3 objectives for this prototype. For the first objective, we would like to analyze the correlation and the relationship between the environmental stressor such as air quality, humidity, and the temperature combining with the brainwave activities using electroencephalogram EEG. For the second objective, we would like to develop a wearable EEG device that capable to capture the brainwave signals in the living environment. For the third objective, we would like to design a better environments for mental well-being and productivity by combining the brainwave activity data from the EEG and the environmental factors. So that's all from the objective part. Now we move to the scope of work slides. This project includes the following aspects. For the first point, our group would like to integrate the environmental sensors such as DHT22 for temperature and humidity, MQ2, MQ4, and MQ135 for air quality, and EEG for brainwave monitoring using 10 to 20 systems. My second point is we would like to test the device usability across diverse users. And for the third point is we would like to validate its performance in various experiments in various environments such as small rooms, open halls, and lakes to ensure the reliable signal capture. So that's all from the scope of work slides. Thank you.
Okay, Assalamualaikum. My name is Muhammad Fikri bin Izzar. So today I will present about the hardware component for our project. So for the first part is the air quality sensor. So first we have the Arduino Uno board, and we have the ESP microcontroller, and we have the humidity and temperature sensor, the HG32, and we have the light ambient sensor for detect light, and we have the output display, I2C display, and we have the five the sensor MQ2, MQ4, MQ135, MQ8, and MQ9. So this sensor will detect a variable gas, which is like carbon dioxide, carbon monoxide, and F. Then we have the breadboard and the Arduino micro USB wire, and also the jumper wire for the connection system. So at the picture, we can see that this our project that have successful connection, and the output can be see at the LCD and at the Arduino IDE apps. So, so for this part, this is a EEG brainwave system. So this project is to find the person that we test to do the simulation for by using the OpenBCI software, by using the microcontroller OpenBCI Ganglion. And so in the experiment, we need to wear the headband sensor, and then which the output from there we can have on the OpenBCI software. We can conclude the person in the relaxing condition or not relaxing. And after that, we have the sim- simplified data to get in the software project, and we can conclude the experiment. So that's all. Thank you.
My name is Muhammad Ashraf. In this demonstration, I will show how EEG brainwave sensor measure stress level and how we integrate additional sensor to enhance its functionality. Our focus is on assessing stress level in living environment using biomarkers and brainwave data. Okay, first we start with the EEG sensor, which we use OpenBCI headband kit for EEG measurement. This device captures alpha and beta brainwave activity, which are critical indicator of stress. This set of data is taken from 22 years old male and display the EEG signal vary as stress level change. The OpenBCI Cyton board can use to sample brain activity EEG, and the board communicates wirelessly to a computer via the OpenBCI USB dongle using RF radio modules. Next, we incorporate environmental and body condition measurement to provide a holistic view from the EEG data. All data collected by the sensor is transmitted using an ESP32 microcontroller, which we use this MQ gas sensor to detect air quality and harmful gases that may influence stress level. We use temperature sensor to monitor the room ambient temperature as extreme condition can impact level of stress. We also use DHT22 sensor to measure both temperature and humidity in the living space. Finally, we use light sensor to record and determine if it contributes to stress triggers. The temperature and the sensor reading are also displayed locally on I2C display for ensuring a quick and convenient access to environmental conditions. This feature is particularly used for monitoring indoor environments where temperature and humidity may influence stress level. By looking to the graph, the ESP32 is able to sending a sensor reading to the ThinkSpeak IoT platform. Once upload, ThinkSpeak process the data and visualize it as graph and chart. The chart show MQ gas sensor, which is MQ2, MQ4, MQ135, MQ8, and MQ9. This detect air quality including smoke, methane, carbon dioxide, hydrogen, and other gases. Now we use blood pressure monitor to monitor the sympathetic nervous system activation, heart rate increase, vasoconstriction, and blood pressure elevation.
Now look at the temple thermometer to measure the body temperature. And finally, we use the finger pulse oximeter to measure two critical indicators of stress: heart rate pulse and oxygen saturation. So in my conclusion, our group explore five various biomarker sensors come together to create a robust system for monitoring stress level in a living environment. Thank you for watching.
Hi, Assalamualaikum. So I am going to talk about the conclusion. So for the project overview, we have integrates IoT technology with an environmental and EEG system for mental stress assessment, and it is a real-time, user-friendly, and effective in analyzing environmental factor impacts on mental health. So some achievement we got from this project is we combines our DHT22 and MQ series sensors with a wearable EEG device. We enabled continuous monitoring of environmental conditions and brainwave activity. And lastly, we data visualization on ThinkSpeak validate correlation between environmental factor and mental stress indicator. So some potential impact from our project are create smarter, responsive environments to support mental health and transform healthcare, workplace productivity, and urban living. And lastly, for further studies, we can provide few recommendations, which are improve sensors accuracy with better calibration techniques, expand monitored parameters to include noise level and particulate matter, and lastly, we can develop advanced stress prediction algorithm. That's all from us. Thank you.